Good morning, everyone. This is one of the most interesting sessions because not every day you can be on the same place with people so bright and so intelligent as the guys here from the scientific group. So first, I will ask Dr. Brian Rubin from the Cleveland Clinic to talk a little bit about how this project began, how they were approached by Norman and the LRG group, and what are the general objectives of the project. And after that, Dr. Annette Duensing from the University of Pittsburgh will give us an update on the work that every team is doing. So please, Dr. Brian.
Okay, thank you, Rodrigo. Glad to see everybody made it in this morning. Man, I have a 7-month-old kid, and people asked me what I did last night, and I was like, oh my gosh, I just found my bed and went to sleep, and I had a full uninterrupted night of sleep. So it was wonderful. Anyway, Annette and I are going to sort of co-do this. We've actually never done one of these presentations where we sort of shared it, so hopefully it won't be too awkward, but we thought we could both contribute. And thanks to Annette, actually, for putting this slide deck together. So this is the LRG Research Group. Here we are in Leuven. We have one in-face meeting per year, and we have several web-based meetings. And we were fortunate that one year we went to Leuven in Belgium, and I don't know if I have a pointer here, but oh, here we go. So this is Maria W. Richter, who we talked about last night. She's one of our researchers, and Maria works there. And so we try to go visit different sites. This year we're thinking about going to the Cleveland Clinic, where I work, although I don't think Norman knows about that yet. But we'll have to talk about that. But anyway, so these are some of the people from LifeRef Group. Jim Hughes, who takes care of keeping track of all the clinical trials and has a fantastic web interface that he's made. Oh, I see a pointer has been produced. Here's Matt Vanderine from Stanford University. There's Jerry Call, sort of the science director from the LifeRef Group. He used to be a builder until his wife got GIST, and then he became an expert on the science of GIST, and he really is a very knowledgeable guy. I'd love to talk to him to find out what's going on. Here's Anette. Mike Heinrich from Oregon Health Sciences. Of course, you know this guy. There's Chris Corliss, also at Oregon Health Sciences. John Fletcher. That's me, and that's Adrian, one of the postdocs from Jonathan Fletcher's lab. But we like to get together once a year and talk about science. So again, this is sort of the group. It's a little bit more expanded. Here's Sebastian Bauer. I couldn't see in that picture, but he's probably there somewhere. Sebastian's in Essen, Germany, and here's Thomas Ordog, who I also didn't mention. He's at the Mayo Clinic, and what this group represents is a diverse group of scientists and physician scientists who have different skills that they bring to the table. Undoubtedly, our fearless leader is Jonathan Fletcher, and all of us, or many of us, came to know Jonathan through postdoctoral research in his laboratory. Sebastian, Annette, and I were all postdocs with Jonathan. Chris and Mike are at Oregon Health Sciences, and this is where the whole Gleevec story got started, so they've been part of the story from day one. Matt Vanderine's a very good geneticist. Thomas Ordog is an expert in the cells that give rise to GIST, the interstitial cells of Cajal. He's a very important component of our group. And Maria W. Richter's group does a lot of mouse modeling and genetics of GIST. And so we all sort of play certain roles in this group. Now, Rodrigo asked me to say, how did this group get started? And so, as I sort of said last night when I was introducing Annette, I think Jerry and Norman from day one were interested in the science of GIST. This was at the time now when Gleevec was called STI 571. It wasn't even really a drug. It was an experimental drug. It wasn't something that was offered to every patient. And they realized that the science was going to be important in pushing forward therapy. And so they would approach scientists at meetings, introduce themselves, just to sort of say, hi, this is who we are, and we're interested in your work. And then they did get some money from Life Raft Group people who made some donations, in fact, very substantial donations. But what really got this group and kicked it into high gear was that Norman was able to approach Dan Vasella, the head of Novartis, the CEO of Novartis. They developed a relationship by being engaged in GIST treatment and asked Dan for a significant pile of money. It was done over coffee and food and a handshake, and the money came forward. And so a large check came from Novartis, which really allowed this research group to coalesce, come together, have all these meetings, and fund. Every single person you see up here is funded individually to do this research through the Life Raft Group, and money that's received both from patients, from caregivers, and also from pharma. So that's the way this whole thing got started. Now, this is a movie actually that Anette took several years ago, and we always like to do this movie because it's sort of a time when we can all come together, and this is the goal of what we're doing. So these are GIST cells. These little lumps are individual GIST cells from a cell line that actually we started culturing when we were postdocs back in probably 1998 or 1999 from a patient, and they grow in a plastic dish now. And what we've done, see if I can get this to work, is to apply Gleevec now, and what we're going to watch is these cells dying. So these are just cells dying. What's going to happen is they move around a little bit because that's sort of what they do in a dish, but eventually they have these little blobs here. So these are cells apoptosing or dying, and that is the goal of our work, is to kill GIST cells. So everything that we do, we enjoy the science. It's very intellectually stimulating, but above all, the goal of what we're doing is to kill GIST cells because that would essentially represent a cure for patients. We're going to watch it again. So here they are. They're moving around. Cells are starting to die here. And that's what it looks like when a GIST cell dies. Okay. Yeah, give yourselves a... I think John's ready for his first joke, by the way. He said, "Do you have any science jokes?" And I said, I'm not really a funny, I don't know. Yeah, cancer jokes. We need some cancer jokes. Anyway, so there's two major sort of, names that we've sort of given to these strategies, if you will. One's the pathway to a cure. One was the D-Day project. So the D-Day project was actually started by Jeroen Pitt and a bunch of his friends, where they actually had a serious fundraising effort to really have a sort of an all-out assault on GIST, and that happened a few years ago. And so, again, we've talked a little bit about this already, but this pathway to a cure, so we have these prioritized projects, a common strategic plan. The things about this group that really make it unique is that we share a lot of common resources. Scientists tend to be competitive, and for reasons that are kind of stupid, don't share a lot of things having to do with getting funding first or getting your paper published first. We've sort of put all that aside and said, look, we're being funded as a group by the Life Raft Group, so we don't have to worry about all this other stuff. How can we share our resources, and how can we collaborate to move the research forward in a more fast and sort of unprecedented way? One of the nice things is that there's a patient registry and tissue bank, so I encourage you to contribute that. You can talk to Jim and Jerry about that if you want to know the details, but that's a very helpful thing that allows us to chase down some of our ideas in actual clinical samples. These are some of the research priorities. You can see the list is quite large. So we're interested in clinical trials. We're interested in primary resistance. So these are just like wild-type GIST that don't respond initially to Gleevec. Secondary resistance is the kind of resistance that occurs after time. Oncogenic signaling is essentially the pathways, the electricity that runs through the cells. Of course, we're interested in wild-type and pediatric-type GISTs, stable disease, KIT degradation, mouse models, et cetera. But what you can see here is this large list. And what we're really... the idea is that we're leaving no stone unturned. You never know when the next really important advance is going to come and where it's going to come from. And so we take this really comprehensive approach, hoping that one of these strategies really gives rise to something that's critical in the sense that we'll be able to either significantly advance our treatment of GIST or to really cure GIST. That is the goal. And we don't even like to talk about a cure that much because it sometimes seems like it's a very high bar, but that is what we're trying to do, is to cure GIST. And I think we all believe it'll happen. We just don't know when, but we're certainly trying for that. Should I keep going? Yeah. So the D-Day project, we call this our all-out assault on GIST. It was a four-pronged whole genome approach. So we got this significant donation from the group over in the Dutch, and it allowed us to do some deep sequencing, some gene knockdown, drug screening, and validation in a really unprecedented way that we hadn't been able to do before. So we used a lot of next-generation technologies, basically, to do that project. I think Annette's now going to start talking. So we've recently put together, so we've published lots and lots of papers together, really over 100 papers between small portions of this research group over the year, but we finally put together a very large, giant sort of paper recently that's currently under review that is, as Jonathan was sort of talking about it, it's sort of an encyclopedia about the genetics of GIST. And I think Annette maybe is going to give a talk for a little bit, and then I'll come back towards the end.